Hi everybody, today we are going to be talking about water. Water is very prevalent on Earth, very important for chemistry, very important for our lives. We want to make sure we understand water. This first picture shows you water freezing. Water, as it gets colder, it freezes. All right, so we need to understand at what temperature water freezes. Okay, so what temperature does water freeze at? Well, you should know that. Think about it. You should have a Celsius temperature in mind and a Fahrenheit temperature in mind. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. Those are two numbers that you should know, and you should have memorized those. If you don't, please memorize them. Water boils. At what temperature does water boil? Water boils at 100 degrees Celsius and at 212 degrees Fahrenheit. The one that we will be using in chemistry is the Celsius number. So it freezes at 0 Celsius and boils at 100 Celsius. This is a very busy curve, and I'm going to show you another one in just a minute. But I figured you might remember things better with pictures than you would remember them with just words. So that's why I did this. All right, we have a heating curve for water. So let me just go down so you can see the heating curve. That's what it looks like. So I'm going to talk about each of these different pieces. There are 5 pieces on here I'm going to talk about. The first piece is down here. The first piece is when the temperature of water is below 0 degrees Celsius. These are all temperatures in Celsius. So when I'm below 0 Celsius, I have a solid, which is ice. Right? Can the ice be below 0? Of course it can. The ice coming out of your freezer is well below 0 Celsius. Right? If you live in Boston and there's ice sitting on the road, yeah, it froze last night, but then the temperature continued to go lower, and the temperature of the ice continued to go lower. But as ice warms up during the day, it gets up to this point, all right, and it's at 0 degrees Celsius. And you'll notice the temperature isn't changing. The concept here is I'm applying heat to ice. I took some ice down here that started out down here at this temperature. I'm warming it up, and eventually it gets to 0 degrees Celsius, and it stays there as it melts. So you'll notice here we have ice melting. So we have both solid ice and we have liquid water at the same time. When that happens, we're at 0 degrees Celsius. Because if we're at more than 0 degrees Celsius, then we're going to have an all liquid. If we're at less than 0 degrees Celsius, we're going to have all ice. So when you have both present, you're at 0 degrees Celsius until all of it melts. Once all of it melts, you have water, and that's this area right in here. So all the way from 0 degrees Celsius all the way to 100 degrees Celsius, you have liquid water. But when the water hits about 100 degrees Celsius, it starts to boil. And that's what this is. And it boils and it boils and it boils for a very long time. Have you ever noticed when you put a pot on the stove and you start the water boiling, it takes a real long time for it to boil? That's what this is saying. All right? So when water boils, it doesn't go above 100 degrees Celsius. It stays there, right, until all the water boils off. Now, once all the water has boiled off into steam, you can continue heating up that steam. If you keep putting heat into the steam, the heat has to go somewhere. It's going into the steam. So the steam can actually go above 100 degrees Celsius, just like your frozen water, which was ice, could go below 0 degrees Celsius. And here's a geyser, right, as an example of very hot steam coming out. And that steam is above 100 degrees Celsius when it comes out, right? So if I look at the heating curve, now with just words down here, you'll notice we have solid ice down below 0, but at 0 degrees Celsius, we have ice melting. So if I take some ice and I start heating it up, it's going to stay a solid until it hits 0 degrees Celsius. And then it is going to melt. And it's going to melt and melt and melt and melt until finally all of it is melted. Once all of it is melted, then the temperature will start to go up as the water starts to go up. It starts to get hotter and hotter and hotter and hotter until the water starts to boil. When the water starts to boil, it stays at 100 degrees Celsius and continues to boil and boil until it's all gone. If you've captured the steam and you keep putting heat into the steam, the vapor or the steam, the temperature of the steam will continue to go up. Right? That is the heating curve for water. It's something you have seen before. It's something you should be familiar with. Right? We have a picture here of some oil and some water. Why is the oil floating in the water? Well, your first response is probably that it's less dense. That's correct. It is. And it doesn't mix either. So This has to do with density. And water and oil do not mix. We'll get into why that happens in chemistry. But the bottom line is the oil's floating because it's less dense. But we have bugs. Bugs can walk on the water. Why can bugs walk on the water? They're denser, they're heavier than the water, so why can they walk on the water? Well, they can walk on the water because there's this thing called surface tension, where water actually has almost a film on top of it. We'll talk about where that comes from in chemistry. Again, you've heard of surface tension before. That's been in your previous classes, so you should at least be familiar with it. And you see that the legs are sitting there kind of deforming the surface tension of the water. Right? So, you need to understand that water freezes and water melts at 0 degrees Celsius, which is also 32 Fahrenheit. Right? If the temperature is below 0, then it's going to be frozen. If it's above 32, it's going to be a liquid. So it melts and it freezes at 32 or 0 Celsius. Same thing for boiling at 100 Celsius or 212 Fahrenheit. When you are going through a phase change, when water is melting, freezing, boiling, or recondensing, right, the temperature remains constant. Ice can be colder than 0, steam can be hotter than 100, and also with water we need to understand that oil is less dense than water, so it floats, and surface tension allows bugs to float on the water. Alright, you got a worksheet to do to make sure that you have these ideas in your head. Once you're done with your worksheet and you feel comfortable, you can come to class and take your test. If you have any questions, please feel free to ask me in class or before or after school. I'll see you then. Have a great day. Looking forward to it. See ya. Bye. That did not work.